Welcome to Easy Alim Learning Simplified. My name is Ruth, and today we are going to be looking at the topic the mole, and our subtopic for today is Gay-Lussac's law. So previously we looked at the molar gas volume and we related some of the Avogadro's law into calculations. So today we will take the Gay-Lussac's law and we will do a few questions that is going to help us to understand the law better. So Gay-Lussac's law of combining volume states that when gases react, they do so in volumes which bear a simple ratio to one another and to the volume of the product formed if gaseous, provided the temperature and pressure remains constant. So remember we are talking about gases, in this case, purely gases. So that is what we are going to be focusing on. So the ratio of the volumes of gases in the reactants and gaseous products are usually expressed in simple whole ratio numbers. So we are going to use ratios, that is the coefficients for balancing as our ratios. Remember previously we were talking about mole ratios. So in this case now we are going to change those ratios now into volume. We call them volume ratios, but it's just similar to how you are getting the mole ratios from the coefficient. Let's do a few questions so that we can see how this law applies. So 450 centimeters cubed of carbon dioxide was reacted with excess oxygen. Write a balanced equation for the reaction and calculate the volume of carbon dioxide formed and the oxygen used up. So first of all, we do the equation. So carbon dioxide was reacted with excess oxygen. It should be carbon 2. So carbon 2 was reacted with excess oxygen to form carbon dioxide gas. So we balanced the equation. You notice that we can put a 2 here and a 2 here, which balances the equation. So we are told 450 centimeters cubed of carbon 2 was reacted with excess oxygen. So we know the oxygen is in excess. The mole ratio is 2. The volume ratio, in this case, not mole ratio, is to 2 is 1. 2 is to 1 is to 2. So we have 450 centimeters cubed of carbon dioxide. And then using the ratio, we know that now the volume of oxygen used up or used in this reaction is going to be 450 divided by 2, which gives us 225 centimeters cubed, and this is also going to be 450 centimeters cubed. So we have written the equation, and then the next question was calculate the volume of carbon dioxide formed, which is 450, and the oxygen used up, we used 225 centimeters cubed. Let's do another question. 150 centimeters cubed of nitrogen gas was reacted with hydrogen. Write a balanced chemical equation. So we know nitrogen gas reacts with hydrogen gas to form ammonia gas. So we balance the equation. If we put a 2 here, it means we have 6 hydrogen, so we have to put a 3 here. So the volume ratio is going to be 1 is to 3 is to 2. So we have been told 150 centimeters cubed reacted with 330 centimeters cubed to form hydrogen gas. So calculate the volume of ammonia produced and the total volume mixture at the end of the reaction. So the first thing that we need to do is to figure out which one is excess and which one was limited. So if we were to use the volume of nitrogen, we know that 150, if we were to use 150 centimeters cubed of volume, for hydrogen would be 450 centimeters cubed. But the ones that we used in the reaction was 330. This tells you that the amount of nitrogen that was used in this case was the one that was excess. So we are going to use 330 instead. So the volume of nitrogen that was used up in this reaction is going to be, now it's going to be 330 divided by 3, which gives us 110 centimeters cubed. So 150 was in excess. So if you look at the amount that was in excess, it was 150 minus 110, which gives us 40 centimeters cubed. And then the amount of ammonia now, because you have chosen to use 330 or 110 in the case of nitrogen, is going to be 110 times 2, which gives us 220 centimeters cubed. So the total volume mixture, we know that ammonia is going to be part of the mixture, 220 centimeters cubed, and the excess nitrogen that was not used up, which is the 40 centimeters cubed, which becomes 260 centimeters cubed. That is the total mixture that was at the end of the reaction. Let's look at another question. Consider the reaction. 2 moles of hydrogen reacts with oxygen to form 2 moles of water. So what volume of steam is formed from 20 centimeters cubed of hydrogen and 20 centimeters cubed of oxygen mixed together? So we see the mole ratio between hydrogen, let's write the equation again, plus oxygen gas to form 2 moles of water. So we used the mole ratio is 2:1:2. If we use 20 centimeters cubed of oxygen and 20 centimeters cubed of hydrogen. Let's use the hydrogen one and see. So if you use the hydrogen one, the amount of oxygen that you are supposed to use up in the reaction would be 20 divided by 2, which would be 10 centimeters cubed. This tells us the oxygen is in excess. So we cannot use like the volume of oxygen to get the volume of steam. So this tells us that the volume of steam is going to be 20 centimeters cubed, and the excess gas was oxygen gas, and it was excess by 10 centimeters cubed. We get it by 20 minus 10, which gives us 10. Let's do another question. 1 gram of an alloy of aluminium and copper were reacted with excess hydrochloric acid. 840 centimeters cubed of hydrogen at STP was produced. Calculate the percentage copper in the alloy. So first of all, we write the equation for the reaction. So it is the aluminium that reacts with hydrochloric acid to form aluminium chloride plus hydrogen gas. So let's balance this equation. So we are going to put a 3 here. A 2 instead, which will give us 6 chlorines. So we put a 6 in front of hydrochloric acid. So that means we have 3 here and a 2 here. So there's going to be 2:6:2:3. So we have been told that 840 centimeters cubed of hydrogen was produced. So we have been told to look for the excess, like the copper that was used, the percentage copper in the alloy. That means we need to get the amount of aluminium that was in the alloy. So we need to get the ratio. If the ratio 3 is equals to 840, what about 2? So if 3 has 840 centimeters cubed, what about 2? So it is 2 times 840 divided by 3, which gives us 560 centimeters cubed of aluminium was used. So we used the molar gas volume. So 1 mole is equals to, at STP is 22,400 centimeters cubed. What about 560 centimeters cubed? With crisscross, 1 times 560 divided by 22,400, which gives us moles of 0.025 moles. So we already have the molecular mass of aluminium, which is 27. So we can calculate the mass of aluminium, which is equals to moles times molecular mass. So the moles is 0.025. Molecular mass is 27, which gives us a mass of 0.675 grams. So the alloy has 1 gram, but for the aluminium is 0.67. So if we subtract 0.675 grams, you get the mass of copper that is remaining, which is going to be 0.325 grams. You have been told to calculate the percentage of copper. So the percentage will be 0.325 over the original, which is 1 times 100, which gives us 32.5%. So that's how you use molar gas volume and Gay-Lussac's law to get the values. For example, in this case, you are looking at the mass. So as long as you have a complete balanced equation with volume ratios, you can be able to get the volume of any substance in the equation. So that's how you use that. So that brings us to the end. So see you in the next session.